So this is going to be a read aloud for Chapter 4, 4.1. So start off here, 4.0 Rocks. That's the title of the chapter. Here's the picture. And then the text below it says, this image is of igneous rock, specifically an igneous intrusive rock called granite. The rock was sliced very thin, mounted on a slide, and viewed in a polarizing light microscope. In a photomicrograph, different minerals have different colors and shapes. The gray and black striped crystals are plagioclase. The blobby gray ones are quartz, and the colored segmented ones are mica. Geologists like to use photomicrographs because the minerals are more identifiable. The textures are also easier to recognize, which gives the scientists clues about the rock's formation. All this makes a rock easier to identify. Chapter outline: 4.1 Types of rocks, 4.2 Igneous rocks, 4.3 Sedimentary rocks, and 4.4 Metamorphic rocks. We're going to go to 4.1 Types of rocks. Lesson objectives: define rock and describe what rocks are made of. Know how to classify and describe rocks. Explain how each of the three main rock types formed. Describe the rock cycle. Vocabulary: crystallization, erosion, igneous rock, metamorphic rock, metamorphism, outcrop, precipitate, rock cycle, sediment, sedimentary rock, sedimentation, weathering. All right. Introduction. There are three types of rocks: igneous, sedimentary, and metamorphic. Each of these types is part of the rock cycle. Through changes in conditions, one rock type can become another rock type, or it can become a different rock of the same type. What are rocks? A rock is a naturally formed, non-living earth material. Rocks are made of a collection of mineral grains that are held together in a firm, solid mass. The different colors and textures seen in this rock are caused by the presence of different minerals. How is a rock different from a mineral? Rocks are made of minerals. The mineral grains in a rock may be so tiny they can only be seen with a microscope, or they may be as big as your fingernail, or even your finger. A pegmatite from South Dakota with crystals of lepidolite, tourmaline, and quartz. 1 centimeter scale in the upper left. So this picture, this part represents 1 centimeter. So this whole thing is several centimeters across. Rocks are identified primarily by the minerals they contain and by their texture. Each type of rock has a distinctive set of minerals. A rock may be made of grains of all one mineral type, such as quartzite. Much more commonly, rocks are made of a mixture of different minerals. Texture is a description of size, shape, and arrangement of the mineral grains. Are the two samples in the figure below the same rock type? Do they have the same minerals, the same texture? So here's sample 1. This is sample 2. Rock samples. That's what it says right there. All right. So sample 1, sample 2. Looking at the chart, sample 1 includes the minerals plagioclase, quartz, hornblende, and pyroxene. For texture, in sample 1, the crystals are visible to the naked eye. Formation, sample 1 is magma cooled slowly. And rock type for sample 1 is diorite. Okay. Sample 2 minerals are plagioclase, hornblende, and pyroxene. Texture for sample 2. Crystals are tiny or microscopic. Formation for sample 2. Magma erupted and cooled quickly. The rock type for sample 2 is andesite. As seen in the table above, These two rocks have the same chemical composition and contain mostly the same minerals, but they do not have the same texture. Sample 1 has visible mineral grains, but sample 2 has very tiny or invisible grains. The two different textures indicate different histories. Sample 1 is a diorite, a rock that cooled slowly from magma or molten rock underground. Sample 2 is an andesite, a rock that cooled rapidly from a very similar magma that erupted into Earth's surface. Three main categories of rocks. Rocks are classified into three major groups according to how they form. Rocks can be studied in hand samples that can be moved from their original location. Rocks can also be studied in outcrop, exposed rock formations that are attached to the ground, at the location where they are found. Igneous rocks. Igneous rocks form from cooling magma. Magma that erupts onto the Earth's surface is lava, as seen in the figure below. The chemical composition of the magma and the rate at which it cools determine what rock forms as the minerals cool and crystallize. The lava flowing is molten rock that will harden into an igneous rock. Sedimentary rocks. Sedimentary rocks form from the compaction and cementing together of sediments, broken pieces of rock-like gravel, sand, silt, or clay, figure below. These sediments can be formed from the weathering and erosion of pre-existing rocks. Sedimentary rocks also include chemical precipitates, the solids left behind after a liquid evaporates. The sedimentary rock is made of sand that is cemented together to form sandstone. Metamorphic rocks. Metamorphic rocks form when the minerals in an existing rock are changed by heat or pressure within the earth. See figure below for an example of a metamorphic rock. Quartzite is a metamorphic rock formed when quartz sandstone is exposed to heat and pressure within the earth. A sample explanation of the three rock types and how to identify them can be seen in this video. And there's a YouTube link. The video discusses how to identify igneous rocks. YouTube link. This video discusses how to identify a metamorphic rock. YouTube link. The Science Made Fun video discusses the conditions under which the three main rock types form. YouTube link. The rock cycle. Rocks change as a result of natural processes that are taking place all the time. Most changes happen very slowly. Many take place below the Earth's surface, so we may not even notice the changes. Although we may not see the changes, the physical and chemical properties of rocks are constantly changing in a natural, never-ending cycle called the rock cycle. The concept of the rock cycle was first developed by James Hutton, an 18th century scientist often called the father of geology, shown in the figure below. Hutton recognized that geologic processes have no sign of beginning and no prospect of an end. The processes involved in the rock cycle often take place over millions of years. So on the scale of a human lifetime, rocks appear to be rock solid and unchanging. But in the longer term, change is always taking place. James Hutton is considered the father of geology. In the rock cycle, illustrated in the figure below, the three main rock types, igneous, sedimentary, and metamorphic, are shown. Arrows indicating the three rock types show the processes that change one rock type into another. The cycle has no beginning and no end. Rocks deep within the earth are right now becoming other types of rocks. Rocks at the surface are lying in place before they are next exposed to a process that will change them. The rock cycle. The process of the rock cycle. Several processes can turn one type of rock into another type of rock. The key processes of the rock cycle are crystallization, erosion and sedimentation, and metamorphism. Crystallization. Magma cools either underground or on the surface and hardens into an igneous rock. As the magma cools, different crystals form at different temperatures, undergoing crystallization. For example, the mineral olivine crystallizes out of magma at a much higher temperature than quartz. The rate of cooling determines how much time the crystals will have to form. Slow cooling processes produce larger crystals. Erosion and sedimentation. Weathering wears rocks at the Earth's surface down to smaller pieces. The small fragments are called sediments. Running water, ice, and gravity all transport these sediments from one place to another by erosion. During sedimentation, the sediments are laid down or deposited. In order to form a sedimentary rock, the accumulated sediment must become compacted and cemented together. Metamorphism. When a rock is exposed to extreme heat and pressure within the earth, but does not melt, the rock becomes metamorphosed. Metamorphism may change the mineral composition and texture of the rock. For that reason, a metamorphic rock may have a new mineral composition and/or texture. Lesson summary. Rocks are collections of minerals of various sizes and shapes. The three main rock types are igneous, sedimentary, and metamorphic. Crystallization, erosion, and sedimentation and metamorphism transform one rock type into another or change sediments into rock. The rock cycle describes the transformations of one type of rock to another. Review questions. Describe the difference between a rock and a mineral. Number 2, why can the minerals in a rock be a clue about how the rock formed? Number 3, what are the three main types of rocks and how does each form? Number 4, describe how an igneous rock changes into a metamorphic rock. Number 5, describe how an igneous rock changes into a sedimentary rock. Number 6, explain how sediments form. Number 7, in each rock type, do you think I'm going to start that one over again. Number 7, in which rock type do you think fossils, which are remains of past living organisms, are most often found? All right. For further reading, there's a link here of an interactive you can go through, and I have the updated link here in this notepad. It's www.learner.org/series/interactive-rock-cycle. Okay, and the points to consider. These are just meant to get your brains going for the next unit. If Earth's interior were no longer hot, but all the processes on Earth continued unchanged, what would happen to the different rock types in the rock cycle? And the second one, stone tools were important to early humans. Are rocks still important to humans today? All right, so that is the end of 4.1. Hopefully this helps. Let me know if it does or if there's something that I could do to make it better. Have a nice day and stay curious.